Hi, I'm James McGuire, and today we're talking about hybrid cloud and edge computing. To discuss that, I'm joined by Ross Brown, Vice President for Oracle Cloud Infrastructure. Ross, hello to you today.
I'm good. Hi, James. How are you?
Good, good. And I know you've got some exciting news. We can talk about a number of topics, but
Sure.
let's make sure we get the news out. So what's new today?
Well, we're announcing a new service that's connected through our cloud as part of our disconnected and connected edge strategy. But I think
Mhm.
it's important for us to frame how we think about hybrid cloud to help that make sense. So, if you
Sure,
don't mind, I'll put it in context for you.
please do.
So, at a very high level, I'll give you a way to think about the market that we look at, which is you could look at hybrid computing options first in the size and capability of the deployment. Is it a small device or is it a big giant hyperscale region?
Right.
And then you look at it in this other control plane aspect, which is it a self-contained device where the control plane and the data plane are running locally,
Hmm.
or is it a remotely tethered device where the device is separated from its control plane, so remotely managed?
Okay.
And if you think about how that builds out, you end up with hyperscale cloud regions, single server disconnected edge devices, and then this notion of remotely tethered compute and storage appliances and whatnot. And our competitors have different offers that come into different parts on this map.
Mhm.
For OCI, our public region, just to keep you up to speed on what we're doing there, we're at 29 regions live now. We have 9. We'll do more than 9 this year. We've publicly announced the locations of the 9 expansions, but more will get done this year. And in 6 of these locations, we have a connection between the OCI tenancy and the Azure instances that are located in the same facilities,
Uh-huh.
where we can give customers a sub 2 millisecond connection between those tenancies for being able to do cross cloud computing.
Gotcha.
Right. So the news today is we're introducing the OCI roving edge device, the Oracle Rover.
Hmm.
The roving edge is a single, or it can be clustered in 5 to 15 node configurations, disconnected edge device. And what I mean by disconnected is it's provisioned through the cloud. You load cloud applications into it. And when you receive it, you can begin operating it in a location that has no network connectivity, low latency network connectivity, or has full bandwidth connectivity, but it will operate without necessarily needing a connection back to the cloud.
Hmm.
Right. So we'll give you a little more detail on that. It is meant to go out of our data center. So it's in a ruggedized case. It's portable. As I mentioned, it's scalable from a single device to a minimum cluster of 5 nodes up to 15. It is low latency, high performance data processing. I'll tell you what's in the box in a moment.
Hmm.
And it creates a very consistent experience around what people do in our cloud. It's provisioned through our console. It's managed through our console. All the VMs and image data sits within your tenancy. So think of it as a physically separate, but still logically connected aspect of your OCI tenancy. What's in it? A lot.
Yeah.
It's a 40 CPU or 80 virtual CPUs with the way we do vCPUs, 512 gigabytes of memory. We put an NVIDIA T4 GPU in it for helping with machine learning refinement model applications. 61 terabytes of NVMe storage in it for block and object. And it's done as a flat fee of $160 per day of possession per node.
Are you thinking that one of the like a certain company might use one of these, or be typically they'd have a handful of these? How
Depends
would
on the
that play out?
application. So if you're thinking about, let's say you want to have um, a traffic application running in a city.
Hmm.
And so there's a lot of video data going on about where traffic jams are, where an accident might have occurred, those sorts of things that you want to do near real-time processing to be able to alter the traffic signals based on what they see on the cameras using a neural model. All right.
Hmm.
That would be one where you've got them scattered around the city, but connected through a WAN connection to be able to update them. But the processing is occurring locally against the visual data that's occurring locally. Does that
Right.
make sense?
It,
In
it
other
does.
cases,
One small point about that is really interesting because it seems like there's this debate about edge computing. Where
yeah,
is the processing going to go on? Is it going to go onto the device, or is it going to go on at back at the home base? And it sounds like with this device, a lot of the processing is going to go on at the device. Am I
either
correct in thinking
either place. It can
either
occur on
place?
the device or it could occur. We don't have customers are going to use it. And I love these arguments of, is it going to occur here or there? Well, it depends
Right.
on the application. Some
Uh-huh.
applications it needs to occur locally, some it can go
Okay.
back. Like
All right.
a great example in oil and gas is you may use a clustered version of these to be able to collect a ton of geotechnical data from a seismic experiment. but the actual computation on that's done much better against a bigger instance where you've got lots of GPUs and lots of capabilities. So
Mhm.
that's an example where you'll collect it, but do the processing later. In the case of doing real-time, image recognition and real-time decision making, that compute will occur locally. So it's app dependent,
Gotcha. Okay.
right? From a experience standpoint, I'll give you a little bit about that. You log into your console, you load virtual machines into it, and they could be running containers, they could be running databases, they could be running any applications you want in the VMs. You provision your object storage into the SSDs, and it disconnects and comes to you.
Hmm.
Um, the use cases we've seen behind this, there's a couple of things that we think are important. Um, if you need cloud capabilities in remote locations we talked about, we wanted to make sure that you could do this in clusters so that it wasn't a single device only is really about data capture of small events, but that you could scale this up locally if you needed to. We wanted to make sure you could process large amounts of streaming data and meet that latency requirements, that near real-time computing that you need to have.
Mhm.
We wanted to make sure that sensors could any sort of anomaly detection or whatnot could make those decisions at location. We also don't think of this as a completely disconnected device, meaning we talk about it being used in a disconnected environment because it's capable of doing that, but
Mhm.
it's just as capable of being used with a network connection that's active and high performance, but you still need that processing occurring locally. So it doesn't always work disconnected in the sense it can work connected as well. It's really a choice customers make is what their use case is.
Mhm. Makes
The other
sense.
thing is because it's running all the applications and data in the cloud and you deploy them to this VM model, you can run anything cloud native. And typically, the experience people have with edge devices is I've got all this wonderful capabilities in the cloud and a very limited set of capture or analytics that we can do locally. And we've really opened that up for a pretty robust device.
Hmm.
The user experience. Go into your console. You provision it with OS image and storage buckets. We ship it to you using secure shipping. You put a PIN code in your console for each device that's required. It could be the same PIN code if you want to be unsecure, but the PIN code is required to, in essence, operate the device when it arrives to you. So that prevents any access in transit.
Hmm.
You consume the services on it. We bill you on a per day basis, and then you either synchronize back using your connection or you return it to us and we sync all the data back into your cloud tenancy. We then apply a NIST 800 cleansing model to it, which is a standard for completely wiping it back to a virginal state. Or if you're really paranoid, like one of our military customers may be, you can destroy it yourself and incur a loss fee and the life if you choose to.
Right. I mean, I guess that's the thing in terms of the short. You're talking about a rental concept, which of course it is a rental idea, but I mean, even a shorter term, would companies not want to have this as part of their regular infrastructure on an ongoing basis?
Sure. And it's still consumed as a service on a per day cost.
Gotcha. Okay.
Like all of the cloud services, there's no cost for the thing, there's only the cost for the use.
And then, of course, so in that instance, there may never be a wipe situation or a wipe fee because they would never need to be wiped or probably
Nope.
never need to be wiped.
It's up to them. By the way, there's no cost for the wipe. There's only a cost if you decide to destroy it.
Gotcha. Okay.
Right. Okay. So that's a little bit about roving edge. Any other questions there?
Yeah, it's really interesting about that. In that, first of all, I'd say that it's interesting in that cloud computing was really the hot emerging technology several years back, and it's still big. And it seems like edge computing, which arguably is or is not part of cloud, it seems like edge is getting a lot more buzz these days than cloud is. That's thought number one. But I guess thought number two is who was it? I think it was Mark Andreessen who said that software is eating the world. But it turns out that lo and behold, hardware still plays a pretty
Yeah,
idea. So your thoughts on either one of those thoughts?
I've got thoughts on both of them. So first,
Please.
on software eating the world, I think
Yeah.
the innovation in software around what we do with data has been incredible. But that innovation has been rooted on top of an assumption about hardware. And I'll pause for a second and say, I think AWS and Azure and other cloud providers have done a great job building amazing cloud surfaces,
Mhm.
but all of them built it on top of a thing that existed for other purposes. I mean, AWS is built on top of their e-commerce engine.
Right.
Azure's built on top of GFS. Google's built on top of the Googleplex. Those existed to run Gmail or to run Xbox Live and Bing or to run e-commerce.
Mhm.
Oracle built our cloud with the notion that we could re-innovate in hardware. So instead of you having to adapt your applications to what is considered cloud, we could engineer a cloud that adapts to your applications.
Hmm.
And I'll argue that Oracle is the first bespoke cloud that was built specifically to be a cloud, as opposed to built for something else, and then we put cloud software on top of it. And so the work we're doing on innovating in hardware is not just on what do we do in public regions and how do we deploy those. And there's a lot of work we've done there that over the next 6 months, you'll see us do more public discussions around our engineering and innovations and stuff we've done there that's quite innovative.
Mhm.
But I do think there's also a discussion here around, is cloud computing a place? Is it an approach? Is it a thing? And our view is it's an approach, meaning
Okay.
cloud computing is this notion of I can have computational primitives delivered to me, storage, networking, compute, and services on top of those that I consume as needed on a service basis. And I can do it in a way that's completely driven not on access to the physical, but based on logical control planes. And so everything can be done through a single console. Everything can be done in a single consistent way, regardless of location. In that context, edge is cloud, in the same way that a private region that we create for a customer is no different than our public regions. It's all the same set of services and the same approach.
Right. And I guess if you look at it one way, and that, take it down to a base level, there's in-house, and then there's cloud, which is popularly thought of as distant from in-house.
Yes.
And then there's sort of this middle region, which is edge, although edge in a sense is kind of this amorphous area that is really everything. So,
Right.
but you're saying that really it's all one compute environment that's not dependent on physical location.
Let me go even further on this and tell you the rest of the story, as it were, that backs up that point of view.
Okay.
The remotely tethered compute and storage appliance for us is our Exadata Cloud at Customer, which Exadata has been around for a number of years as a performance transaction processing engineered hardware platform for our database. We've turned Exadata into a complete service model where you get, in essence, an on-prem, high performance, 400 CPU, massive storage rack that's capable of running the fastest transaction processing on the planet. But all of it is remotely managed by Oracle, but in your data center. So the location is in your data center. It's all public cloud hardware, software APIs. It's managed through your control plane. We put autonomous database, so all the patching and maintenance and optimization of the database is done by us using machine learning and tooling on our side. But it's running local. And the reason it's running local is because the latency and performance needed by those customers requires local capabilities. But what they don't want is the management of it. They don't want to have to maintain it and optimize it and tune it and do all that stuff. So we do that as a service.
So you're really saying it's public cloud in-house.
Yes. Hold that thought. That gets even bigger for us.
Okay.
The last part for us is what we call dedicated region cloud at customer. And this is something that we launched in July that's gotten a tremendous amount of market feedback from enterprise customers. What dedicated region cloud at customer is a full OCI region, 3 fault domains. It sits in 2,200 square foot of a customer's data center, but it is the exact same as our public regions, just for a single tenant within their data center. So we'll deliver the entire OCI cloud capable of running our Fusion applications as SaaS platform applications, capable of running all of our compute, storage, and networking. This has all the GPUs you want in it. It could have Exadata services running in it. All of those things are there, integrated in the customer's data center in a cage that we then manage remotely, do all the maintenance, updating, tuning, everything on. And the magic part behind it is it's the exact same price as a public region. There is no cost for their hardware. There is no rental of this. It's the exact same as a public region. The only commitment is you have to commit to spend at least $6 million in consumption per year, which many cloud.
So the figure it's 500,000 per month from what I saw. Yeah.
And most customers who are looking at, and just take 2 workloads, take the Oracle applications and the VMware tenancies that they have on-prem. Most customers in the enterprise blow past that 500K number just on those 2 workloads, which are 2 workloads that in particular have difficult times going to public cloud. So the ability to run those in our environment, you can run those in public regions or you can run them in a dedicated region. But if you want for data sovereignty, for latency, for performance reasons to have it local, we'll do it. Right? Yeah. So that notion of cloud as an approach, We'll put the cloud in your data center. We'll put the cloud at the edge. We'll put high performance, but cloud controlled devices in your data center. Or you could bring everything to a public region and have the exact same experience and the exact same sort of commitment to hardware execution and performance.
Okay, well, this is my one big picture question for you then.
Sure.
It sounds like, there was a time probably in the earlier days of clouds in 2010 through 2012 where people said, oh, someday it's all going to be it's all going to be public cloud. There will be no more data centers. And here we are in 2021. It turns out that, guess what? There are still data centers.
Yeah.
Although there's some that say, yeah, okay, there still are data centers, but if you look long term, if we're looking at, say, the year 2030, for goodness sakes, it's not necessarily, maybe there will still be, or maybe they'll be really dying out. So it sounds like this approach is or is not, correct me if I'm wrong, dedicated, and the world will still have data centers pretty much for the foreseeable future. Or is that beside the point?
It depends on the customer. And this is the thing about trends and statements of like, the world's going this way. Well, no,
Right.
There's a new thing. The old thing still exists, and there's no necessary thing that says you have to move to the new thing. And so generally, if you can get out of the data center business, that's probably a good idea.
Yeah.
There are people who can't get out of the data center business, either for regulatory reasons, for performance reasons, for data sovereignty, for security, for a number of those things. So one of our customers for dedicated region is Demura Research, who uses it to run Tokyo stock market applications. Well, that's a highly secure application that you don't want any tampering with. So controlling access to those environments is incredibly important. It's also a regulated environment. Similar for hospitals who have large data sets where you've been able to move patient data in the US to public cloud since 2018, but internal policies at a lot of hospitals still don't want to do that. Right. This is a great platform for moving all of your patient accounting records and transactions over to, keeping it in your data center in a controlled, regulated manner, but giving up having to maintain any of the environment.
Interesting.
Yeah, so I think you'll still see people in the data center business for quite some time, but only because it makes sense for them to be in it, not because they have to be.
Right. And some of them, of course, have invested an untold fortune in it and can't get out of it for the reasons you talked about.
Well, and that is an argument for some of our customers. Is I have 5 years, 3 years left on this data center contract, or I own the building and I'm trying to sweat the asset down. Is it easier for me to run it locally because I've already got it here? Well, sure. Right. As I decommission on-prem hardware, I bring in a dedicated region, and over the life cycle of my thing, I'm going to keep building out dedicated until I get to the point where it's like, okay, now it's time to move it all to the public cloud and give up my data center and sell it off. Right.
Okay. So you do foresee a future where the data center would be more of a dying beast than it is today, perhaps?
I try not to predict the future because customers do amazing things with technology. And as soon as I say I think data centers are dying, somebody's going to come up with a use case that's going to accelerate them. So I don't know what the future holds. I know the economics are trending towards it doesn't make sense to own large buildings with power consuming stuff in it.
Right. I guess my last question on we have to go here, but I guess if you want to look into the future, now I know you don't want to exactly predict the future, but if the extent that you would say look 5 years out and see something that you see happening either for the Oracle clouds or the cloud market itself, what do you think might be a key trend that people should keep their eye on?
Innovation in hardware matters. The innovations that we're doing in the underlying infrastructure will yield benefits for what you can do in the platform on top of it. I mean, I will say that as a broad 5-year statement. Things you can do at the platform services layer are driven by what you do in the infrastructure. And the better your infrastructure is, the more performant, the more scalable, the more capable, the more it opens up opportunities for better performance in those things. And so we've focused an awful lot on our infrastructure as a service since we've started, because we think there's innovation still remaining to be done there, and we want to lead that. That doesn't mean we're not going to invest just as aggressively on the platform services, but having this foundation gives us so much more capabilities for what we could do there.
I like the sound of that, like innovation and hardware matters. Because whenever someone quotes that famous quote of me, hey, software is eating the world, I'm going to say, but Ross Brown said that innovation and hardware matters.
I've got a three-letter acronym. No, it's not an acronym, it's an initials. It is an acronym. I got a 3-letter acronym that will prove my case that hardware matters.
Oh, good.
It's ARM.
Oh yeah, right.
Right. I mean, we're releasing an ARM service soon. AWS is an ARM service. The Mac's gone ARM. Hardware matters, and we'll talk about ARM when we get there. But there's a ton of work that goes into how do we build what customers are going to need for the future, and how do we innovate on hardware that opens up new capabilities. NVIDIA is doing amazing things with
Right.
GPUs and with backplane controls and all sorts of things. So we see all this innovation going on, and it feels like if you're running cloud native VMs on top of it, it's hard to take advantage of that innovation truly. Whereas, we're building out bare metal capabilities and provisioning these things so people can do more with it. And I think what we'll do in the future on it will be even more.
Interesting.
Yeah.
Well, Russ, I think you've said it. Do you want to add one more thought, or we're good to go? I mean, you let me
I
know.
appreciate your time, James. Thank you
Yeah.
very much.
Thank you very much. Take care.
All right, thanks.